Hello, let's evaluate this integral. I equal to integral 0 to 1 ln of 1 minus x by 1 plus x dx. Right? So let's start. Let's consider x equal to 1 minus t by 1 plus t. That implies dx will be 1 plus t whole square into 1 plus t into minus dt, right? Then minus of 1 plus t into 1 minus t into dt. So this will be, if you take dt out of it, this will be minus 1 minus t minus 1 plus t into dt by 1 plus t whole square. Plus t minus t will go, then this will be minus 2 by 1 plus t whole square dt. Right? Then what about the integration limits? If x equal to 0, then t must be 1, right? To get x equal to 0, 1 minus 1 will be 0. If x equal to 1, then t must be 0, right? That is, I will be integral 1 to 0 ln of 1 minus of 1 minus t by 1 plus t by 1 plus 1 minus t by 1 plus t into dx is minus 2 by 1 plus t whole square into dt. So I will be these two, bring it out of the integral. Because of this minus sign here, integral limits will get changed. Then this will be 0 to L, 1. Then this is ln of 1 plus t minus 1 plus t by 1 plus t by, this will be 1 plus t plus 1 minus t by 1 plus t, right? Minus 2 is gone, then the remaining here it is 1 by 1 plus t whole square dt, right? This plus 1 minus 1 will go, then we are left with here it's plus t minus t will go, right? Then I is 2 into integral 0 to 1 ln of 2t by 1 plus t. Then this will be, the denominator is 2 by 1 plus t, right? Then this will be 1 plus t by 2 into 1 by 1 plus t whole square dt, right? These two will go off and one of this 1 plus t will get cancelled. So we are left with I equal to integral 0 to 1 ln 2t minus of ln of 1 plus t, right, by 1 plus t dt. Fine. Then let's evaluate this step by step. So I can be written as integral 0 to 1 ln ab is ln a plus ln b, right? So ln 2 by 1 plus t dt plus integral 0 to 1 ln t by 1 plus t dt minus the third integral is integral 0 to 1 ln of 1 plus t by 1 plus t dt. So let's consider this as I1, this as I2, and this as I3. So let's calculate first the I1. I1 here it is 0 to 1 ln 2 by 1 plus t, right? And this is ln 2 is constant. 1 by t is ln of 1 plus t, and the integral limits are 0 to 1. This will be ln 2 into 1 plus 1 will be 2, right? This will be ln square 2. If t equal to 0, then it will be ln 1, then it will be 0. It will not contribute. So I1 is ln square 2. Then let's try to figure out I3. That I3 is integral 0 to 1 ln of 1 plus t by, as you can see there it is 1 by 1 plus t, right? You can write it in the form of d of, right? As you know, d ln x is 1 by x, so we have written this form, right? Then you can apply these limits, I mean solve this integration limit. Consider this as u and this as v dash. So it will be uv ln of 1 plus t into ln of 1 plus t, integral limits are 0 to 1 minus of integral 0 to 1 u dash into v, right? U dash will be 1 by 1 plus t into v, right? ln of 1 plus t dt. As you can see here, when t equal to 1, this will be ln square 2. I mean, you can easily see this, right? 1 plus 1 will be 2. This will be 1 plus 1 will be 2. Then this will be ln square 2. When t equal to 0, ln 1 will be 0. Then it will not contribute. Then this will be, as you can see, this is the same I3, right? This is I3 is integral 0 to 1 ln of 1 plus t by 1 plus t, I3 case. So this is I3 again. Here it is I3. That implies 2 I3 is ln square 2. That implies I3 is half of ln square 2. Then we have integral 0 to 1 ln t by, we need to figure out I2, right? Integral 0 to 1 ln t by 1 plus t, ln t by 1 plus t dt, right? This can be, we'll apply the same procedure. This will be ln t into 1 by 1 plus t can be written as d of ln of 1 plus t dt. Sorry, there is no dt, right? Yeah. So now apply v dash form. Then this will be I2 is uv, right? This will be ln t. Then this will be ln of 1 plus t integral 0 to 1 minus of integral 0 to 1 u dash will be 1 by t, and this will be ln of 1 plus t dt. As you can see here, I2 is, when t equal to 1, this will be ln 1, it will be 0, minus when t equal to 0, this case it will be ln 1, then this will be 0, minus of integral 0 to 1 ln of 1 plus t by t dt. That is, this is not contributing anything. I2 is minus integral 0 to 1 ln of 1 plus t by t dt. Fine. We know the formula for ln of 1 plus t is summation n equal to 1 to infinity minus 1 whole power n plus 1 into x power n, sorry, here our case is t, right? T power n by n. So now I2 will be minus integral 0 to 1 summation n equal to 1 to infinity minus 1 whole power n plus 1 into t power n by n into, there is one t there, right? This t into dt. So I2 equal to minus of, bring the summation out, 1 to infinity, and these m terms are constants in the integral, minus 1 minus whole power n plus 1 by n. Then this will be integral 0 to 1 t power n by t will be t power n minus 1 dt. Fine. Then this will be minus summation n equal to 1 to infinity minus 1 whole power n plus 1 by n. This will be t power n minus 1 plus 1 by n minus 1 plus 1, which is t power n integral 0 to 1, right? T power n by n, right? So I2 is minus summation n equal to 1 to infinity minus 1 whole power n plus 1 by, when you substitute the limits, 1 power n is 1 and 0 power n is 0, so it will be n square into 1 n square, right? Then how will you proceed further? As you can see, let's do this summation. Let's try to explain how it will look like. Summation n equal to 1 to infinity minus 1 whole power n plus 1 by n squared. When n equal to 1, it will be 1 plus 1, right? Minus 1 square is 1. Right? When n equal to 2, it will be minus plus 1 by 3 square and so on. As you know, it looks like a Riemann-Zeta function, right? Riemann-Zeta function of 2 is 1 by 1 square plus 1 by 2 square plus 1 by 3 square. These summation limits is pi square by 6, which I have explained in my previous videos, right? But in our case, it is 1 by 1 square minus 1 by 2 square plus 1 by 3 square. I mean, the summation here it's not the total summation, it's getting plus and minus alternate times, right? So this is how will you write it? Riemann-Zeta function of 2 as summation n equal to 1 to infinity, right? 1 by n square, right? This is a combination of every number. Then split it into two terms, right? As summation k equal to 1 to infinity 1 by 2k minus 1 whole square plus summation k equal to 1 to infinity 1 by 2k whole square, right? This will be summation of odd numbers. This is summation of even numbers, I mean to say. So let's try to figure out this term first. This is summation k equal to 1 to infinity, right? 1 by 2k whole square is, this will be converted as 1 by 2 square is 4, right? 1 by 4, fine, 1 by 4 into summation k equal to 1 to infinity 1 by k square. This is again Riemann zeta function of 2, which is 1 by 4 into pi square by 6, which is pi square by 24. Then our odd number case will be summation k equal to 1 to infinity 1 by 2k minus 1 whole square is, this will be right, this is pi square by 6 total minus even case. Even case is pi square by 24. Then if you take pi square as common, this is the 1 by 6 minus 1 by 24, which is pi square into 24, right? This will be 24 6 fours minus 1. This is 3 pi square by 24. Fine. What about our case? Our case is this is 1 by 1 square minus 1 by 2 square, right? That means summation of our case is 1 by 1 square plus 1 by 3 square. That means odd numbers minus of even numbers. Our case is I3 is, sorry, this case, right? I3 is minus of, right? Sorry, I2 is summation n equal to 1 to infinity. Our case summation 1 equal to infinity minus 1 whole power n plus 1 by minus 1 whole power n plus 1 by n square. Our case is, as you can see, it is summation of odd numbers minus of even numbers. This is summation k equal to 1 to infinity 1 by 2k minus 1 whole square minus of summation k equal to 1 to infinity 1 by 2k whole square. For the odd number case, we figure out that it is 3 pi square by 24 minus, for even case, summation 2 square is pi square by 24. This is 3 pi square minus pi square is 2 pi square by 24, which is pi square by 12. Pi square by 12 can be written as 1 by 2 into pi square by 6, which is again half times of the Riemann zeta function of 2, right? Then ultimately I is as you can see here, I is I1 plus I2 minus I3, right? I equal to I1 plus I2 minus I3. So I1 is, I1 case is, I1 is ln square 2. I3 is half ln square 2. I1 is ln square 2. I3 is minus half ln square 2 plus I2 is, our I2 case is this, right? I2 is minus of this summation. So minus of 1 by 2 into Riemann zeta function of 2. So this will be half ln square 2 minus half Riemann zeta function of 2, which is ln square 2 minus Riemann zeta function of 2 by 2. So this is the solution. Finally, integral 0 to 1 ln of 1 minus x by 1 plus x dx is ln square 2 minus Riemann zeta function of 2 by 2. So this is a solution.